Ever wonder what the absolute maximum an economy can produce really is? It sounds like a simple question, right? But the answer unlocks one of the most powerful concepts in all of economics. Today, we're going to build that very idea from scratch. We're going to discover something called the production possibility frontier. So let's imagine a really simple economy. It only produces two things, cotton and honey. And in this economy, we have three different groups of workers, each with their own unique talents. You've got Group A, who are like honey-making wizards, but not so great with cotton. Then there's Group B, they're the exact opposite, total cotton experts. And Group C, they're kind of decent at both. Okay, so here's the puzzle we're trying to solve. With these three groups, what are all the possible combinations of cotton and honey we can make? What's the absolute most efficient limit of what our little economy can churn out? Let's figure it out. Now, to figure this out, we can't just throw people at jobs randomly. We need a smart strategy. And the key here isn't about who's the best at everything, but who's the most efficient at each job. This brings us to a huge idea in economics. And that idea is called comparative advantage. Now, here's the part that might bend your brain a little. It's not about who's the absolute best at something. It's all about who gives up the least to do it. And that thing you give up, in economics, we call that the opportunity cost. And believe me, that's the secret sauce to all of this. So what's next? Well, it's time to roll up our sleeves and crunch a few numbers. We need to figure out the exact opportunity cost for every group and for both goods. This is going to tell us exactly who should be doing what. All right, the numbers are in, and check this out. To make 1 ton of cotton, Group B only has to give up 1/3 of a ton of honey. That is by far the lowest cost. So boom, they have the comparative advantage in cotton. Meanwhile, for honey, Group A is the clear winner. They give up way less cotton to make a ton of honey, so our strategy is set. Group B focuses on cotton, and Group A focuses on honey. Okay, now that we know who's best at what, we've got all the puzzle pieces. We can finally start to build our graph and see what our economy's maximum potential actually looks like, one step at a time.
Let's start with an extreme scenario. What if we told every single person in our economy, Group A, Group B, and Group C, forget honey. From now on, you're all making cotton. What would that look like?
We just add it all up. You get 5 times from Group A, 12 from Group B, and 14 from Group C. That gives us a grand total of 31 tons of cotton, and, of course, 0 honey. Let's mark that down as our first point on the graph. Okay, but an economy can't live on cotton alone. People want some honey for their tea. So if we want to start producing honey, who should we switch over first? Well, obviously, we're going to pick the group that's most efficient at it, our honey specialists, Group A. And just look at what happens. We lose the 5 tons of cotton Group A was making, so we're down to 26. But in return, we get a massive 20 tons of honey. That is a fantastic trade-off. We gave up a little cotton for a lot of honey. Let's plot that new point. All right, the demand for honey is still growing. People want more. We've already used our best honeymakers, Group A. So who's next? We look back at our opportunity costs, and yep, Group C is the next most efficient. Let's move them over to honey production. So we take Group C off cotton duty. That means we subtract their 14 tons, leaving us with just 12 tons of cotton. But on the flip side, we add their 14 tons of honey to what we already have, for a new total of 34. And there's the third point for our graph. We're so close to the other extreme now. There's only one group left making cotton, and it's our die-hard cotton specialists, Group B. To find that final point on the graph, where we're making the absolute maximum amount of honey possible, we have to switch them over too. And here we go, the final move. We lose those last 12 tons of cotton, taking our cotton production all the way down to 0. But we gain Group B's 4 tons of honey, pushing us to a maximum honey output of 38 tons. And with that, we have all the points we need to draw our curve. So now for the big reveal. Let's connect those dots. This shape we're about to see isn't just some random line on a graph. It tells a really powerful story about what our economy is capable of. This curve is our production possibility frontier, and it shows us 3 really simple but crucial things. Any point on the curve means we're being perfectly efficient. We're maxing out our resources. Any point inside the curve means we're slacking. We could be making more of something. And any point outside the curve, well, that's just a fantasy. It's impossible with the workers and tech we have right now. But hey, did you notice it's not a straight line? It bows outwards. Why is that? Well, it comes back to that opportunity cost idea. At the beginning, switching to honey was cheap. We moved our best honey makers and got a huge payoff. But for that very last bit of honey, we had to switch our best cotton makers, and we gave up a ton of cotton for just a little bit of honey. In other words, honey got more and more expensive. So after all that number crunching and dot connecting, what's the big takeaway? What have we really learned by building this curve? It all boils down to one incredibly powerful concept: specialization. And here's the bottom line. When each group does what they're most efficient at, not necessarily what they're best at, but what they do with the lowest opportunity cost, the entire economic pie gets bigger. The total output is maximized. That right there is the awesome power of specialization. It's the engine that drives productivity. And that leaves us with one last massive thought to chew on. We just saw this work for a tiny imaginary economy with 3 groups of people. But what happens when you scale this idea way, way up? What if Group A and Group B aren't just workers, but entire countries? What you've just figured out is the fundamental logic that drives almost all of global trade. Pretty cool, huh?